To first understand substitution, we must think about it in terms of equality. So first we will know that in order to solve for an x-coordinate between these two systems, we will have to set it equal to one another. Then we would logically isolate the x variable and solve accordingly to find that the x or coordinate of the solution is x equal to negative 2/3. Then we will plug that back into the solution to find our y coordinate. The reason why this is important for substitution is that solving with equality itself is substitution, as we are substituting the y variable for one equation by substituting in with the x expression that equals y for the other expression. And this is a critical concept of substitution. Similar to the previous example, you're going to isolate and solve for the variable y, but just as a reminder, you could also solve for the variable x. It doesn't matter which variable you solve for. So we will solve for y in the first equation, isolating it in terms of x. Then, as in the previous example, we are going to substitute the other equation in the system with the current equation we have here. So this way we will be able to solve for our x variable. And this will give us our x coordinate. Solving for the equation, we see that the x coordinate for the system is x equals 0. So we'll mark that up above. Then we could also find the y coordinate if we desire by plugging it in back into the equation. It could be either equation since both of the equations are equal at this point. And we see that y equals 1. So this is one way to find the coordinate point for a system. So like all substitution examples, we first have to choose a variable that we're going to isolate. So it looks like the first equation, we just need to add 7y, so it looks like the easiest equation to isolate a variable. So I'm going to isolate the x variable. Remember, it doesn't matter which one we isolate. Then I'm going to write the bottom equation here. Now that we know what x equals for the first equation, we could substitute that into the second equation by replacing what x equals in the first equation and placing that in terms of y into the second. Then we have to distribute it. That will get to 35y minus 55 plus 2y. This will equal negative 18. Then we will solve for y by isolating y. So that will be 37y. Then we'll have to add 55 to the other side to negative 18, and that will equal 37. Then we'll get y equals 1. So now we have one coordinate point for our solution. Now we need to find the x variable, and we could do this by plugging y back into the original equation, as both equations are equal at this point. And that is going to equal negative 11. So x minus 7 equals negative 11. We could find x by adding 7, which would equal negative 4. Thus, we just solved the equation, and the solution is negative 4, 1.